Hey there, welcome back to Farmcraft. I'm John. We're getting back to work on my dump truck. If you didn't see the last video on this, I've got a problem with diesel getting into the engine oil, and it's diluting it so much that it's going to trash the engine if I don't do something. Of course, many would argue the engine's already trashed because it's an 8.2 liter diesel Detroit. That said, this engine runs really well. I like this truck. I'm going to try and save her. So in the last video, I went after the easiest solution for diesel getting into your engine oil, and that would have been from the fuel pump. And I discovered that was not the problem after a lot of work. So unfortunately, that leaves the injectors. Now this is a V8, so it's got two heads, two racks, so we're gonna have to do both sides, obviously. At the end of the last video, I also noticed that the left bank was definitely not contributing as much, so I suspect I'm gonna find more issues over there. We're gonna tear into this thing and see if I can't get it fixed. Now, the kind of injectors and fuel system that's in this truck is old, antiquated, used specialized tools that I don't have, and there is a very real chance that I am going to take this thing apart and not be able to make this thing run again. In which case, that might be the end of the road for her. I don't know. Obviously, I hope that's not going to be the case, but that is a very real possibility here. We're going to tear in and see what happens.
Let me cut in to say this is a Detroit diesel engine. They made and continue to make some really good engines, but this is the infamous 8.2 liter Detroit. It was an early attempt at a four-stroke engine for the company. It was plagued with poor reliability, low power, and was hands down the worst engine they ever produced. It's a very different animal from the older two-stroke Detroits like the 71 series and the 92 series, known as the Screamin' Jimmies. Those were reliable workhorses with good power-to-weight ratios, but they weren't very fuel efficient and weren't good on emissions, so that led the company to make the 8.2. But don't misunderstand, all the Detroit four-strokes aren't bad. They went on to make the Series 60, which is an excellent four-stroke engine. So, in short, you don't want an 8.2 Detroit. Trust me. But what I'm working on in this video is the injectors in the fuel system, which is pretty darn interesting, I have to say, and also worth learning about because it applies to the two-stroke diesels as well.
The first thing I want to do, though, I'm going to back out of here. We're going to get out the power washer, and I'm going to power wash the engine again, and hopefully make this process a little more tolerable. All right, I'm going to hose that down with degreaser and do all that again, but you don't need to see that. Just imagine backing the video up a little bit and watching that over.
Okay, so I'm going to start out on the easy side. This valve cover is much more accessible, and then I can kind of figure out what I'm in for. So looking at this, these are heater hoses. I can probably pull those out of the way if I need to, but it's just going to be easier, and it's easy enough to take that off. This is probably going to need to come off. This is, I believe, just a lifting hook for the engine.
Be nice if I could just unplug it, but there's no plug. It's fine right there. That won't be in the way. These things don't feel like they have any fluid in them, and if that's the case, I'm just going to take them off because they are right in the way. I might have deceived myself because it's leaking. Uh-oh. Yeah, I should have known. That was stupid. Let's see, this bracket is definitely in the way. Wow. So it's not lost on me that this side seems to be the one performing the best, and this side is the easiest one to get to. It kind of makes me wonder if somebody in the past skipped the other side because it's going to be a pain. There's a bunch of stuff in the way. an engine lifting hook plus the exhaust manifold bolts. Let's take the valve cover bolts out. Will it come out? It's got hard lines back here. Yeah, it might be tough to get that out of there. Doesn't matter how many times I wash it. Yeah, I gotta get that out of the way. See, the problem here is this hard line is really right in the way, and the thing is curved out, so you know you'd want to be coming in there, but you can't, so you have to come in at an angle. And I don't know if sockets, there's not room. It seems really stupid. Just give me room to pull the valve cover off. Hey, it moved. One of them loose. Yeah, I got all three of them loose. Fat fingers won't fit in there. Really? Oh, there's another one. Turkeys. All right, so that allows me to get that off of there, doesn't it? Good grief. Okay, we're in like sin. Yeah, I was thinking I'd leave that there because it would just make reassembly easier, but it's not going to be that hard to put back on, and it's still going to be in my way, so I'm going to take that off. Okay. All right, so obviously what we have here is, this is exhaust valve, intake valve, injector, and push rods. Those are all coming up off the camshaft. Everything looks pretty reasonable. An old cork gasket. A little rusty, but not too bad. So now I need to take this rocker shaft assembly off. Supposedly there are supposed to be numbers on the valve cover that tell you what each specific injector is supposed to be on your engine. Something that was determined at the factory, and there's nothing on my valve cover to see. If it was there, it was a sticker and it's gone. That's lovely. This thing runs okay. The issue is the seals that are on the injector down in there are leaking, and it's dumping the fuel either into this valve cover or into the cylinder itself. Let's get this out of the way. Maybe. Ooh. Oh, each one is separate. I was thinking that was one shaft all the way down. Okay, yeah, I'm gonna have to make sure I stay organized here. Yep. So this push rod actuates on the camshaft, which then pushes on the injector, which is surprisingly easy to push. I expected more resistance. Okay, we're on the right side of this engine. These are the even numbered cylinders. So this is number 2, this is 4, this is 6, and 8. Six and 8. So here's the governor. Here is the control rod coming from the governor, and it pushes on this right here and rotates that. So that is the rack movement. And these little push rods on each injector are changing the amount of fuel that gets injected. And those are all moving freely. Well, it's not a lot of difference between there's idle, there's full throttle. So now's where it gets interesting. You're supposed to measure the injector height. The timing is affected by the height of the injector, and when it starts pushing is when it determines when the fuel is actually going to be squirted into the cylinder. So if that injector was up a tiny bit, it would inject that much earlier. As soon as this push rod starts getting pushed on by the cam, it's going to push on this earlier. If it was a little lower, it's going to push lower. My understanding is we'll look at this once we take one out, but when you put the injector in, you can rotate it kind of like on a thread, and it will adjust the height. And then you tighten it down with the clamps. But looking at it, I mean, I think I can just measure between the head right there and the top of the follower and get very precise on that and note what each one is before I take it off. And then at the very least, I'll be able to put it back where it was. So yesterday I really got into the manual and studied this thing, trying to get into the details. And again, I've been getting bad information. You know, a lot of times when I search the internet or use AI, I can get really good information on how to fix things. But I think the older and the more obscure the engine, the worse it's going to be. Just because there's not that much information out there. And what is out there may or may not be true. And if what is out there is wrong, that's what you're going to get. Garbage in, garbage out. AI led me to believe, I'll admit, that the injector height off of the head was set by rotating it, but looking in the manual, that's just not right. That injector height from the head is set. They just bolt into the head. That's the end of that. Injector height is actually set on the rocker arm, and you need a special tool to do it. And I'm not going to be able to do it without that tool. There might be a way to make your own tool if you knew what the specs were, but I don't. The tool comes with like a calibration block that you use to set the height of the dial indicator, and then you put it on your setup and it will then give you an accurate reading. That means by all rights, I really could just pull these injectors out, put new ones in, leave the adjustments as they are, and hope for the best. That is one option. But I also learned in the manual that the specifications for what the injector heights are supposed to be should be on the left valve cover. This is the right valve cover. So we're going to put this back, and we're going to head to the other side and get to work on that. It is not going to be easy getting that valve cover out of there, I don't think. But we'll hammer away at it until we get it. See the fun we have in store for us on this side. All these wires, air hoses, and the steering column are all on this side right in front of that. This is the compressor, and it's got a support bracket here. Yeah, there's going to be a lot more to disassemble over here. It goes way back into that guy. I don't even know what that is from here. What is that? I think that is the clutch pedal. I'm mentally preparing myself. This is going to be a lot of disassembly. Okay. What the heck am I going to do with all these wires? I got to get that out of the way. Breather hose. What am I going to do with all these wires? I hope that's not where the information was. Not having real good luck with information online, but they were saying that it might be on the inside of the valve cover, which would make sense. That'd be a good place to put it. So I'm going to hold out hope for that. It'd be really nice to be able to get that info. But this line is in the way. That's got to go. So this line, not a big deal, but this, the hard line at the bottom is. And that is on this support bracket that is bolted to the frame. And I reach around the back, I can feel there's nuts on the opposite side. And there's two very rusty bolts that I don't have access to the heads. That's going to be fun. think we're going to do a little bit of a farmer hack on this one, because I just know getting those rusty bolts out with the nuts on the other side that I can barely touch is going to cause a lot of profanity. And all this is a support bracket for that line. So what if I just cut one side of it, bend it, get the line out of there, and then I can bend it down. How about that? Valve cover's already starting to look removable. I just need to deal with that and that. All right, future John. This harness right here has this little black wire coming out of it, and it plugs in right there. Not sure what that is, but getting that unplugged allows me to really pull these out of the way. All right, now let's go push the clutch and see if that's what that is.
Yep, that's the clutch.
I think I can just take it out on the part under the dash and just slide that whole thing out of the way. Hopefully I can get this cotter pin out of here. So here we are under the dash. That's what happens when I push the clutch. So this is the rod that's going down there. And I just need to disconnect that upper portion. Yeah, I just got that out of there with that. In theory. Wasn't too bad. Well, so far, I shouldn't say anything, but it's true. Things are going better than expected. And when I was under there, it looks like the nuts on the back side of these bolts are welded on. So I think I can just unbolt this without a big headache, if you have the right size socket. Yeah. I know y'all can't see much, but there's not a lot to see. I'm just taking these bolts out. Pretty sure the valve covers were both leaking, which is probably a lot of why this engine is so disgusting. That's a fun one. There it is. Got it. Only a moderate amount of pain. How did I ever live without the cordless ratchet? I think they're all out. That thing doesn't want to move. There we go. Say it's been a while since that thing was off. Wires are going to be a nightmare. These right here especially, because they're pretty tight. There's no room for it to go that way. Man, I end up having to disconnect all of those. Pretty sure they all just go down to the starter. Shouldn't be too bad. So let me disconnect the battery and then we'll head down there. All right, here we are underneath. So that's the small wire loom there, and this is the bigger one. And those wires look lovely. I don't know if you can see that. They're mostly frayed. Wow, those are positive wires. Those bare wires right there hook to battery. That's lovely. That's what we call a can of worms. That's all right. I'll get them disconnected, pull them up there, and then I can get a better connection on that. Those are all disconnected now. We should just be able to pull these up. There's only a couple strands still hanging on. Nice. We'll see. Right there. I can probably get it by feel with a wrench. Certainly can't see it. It's actually spinning, the old two-finger tickle. That's going to be fun to put back. Now, You're still gonna make me take all that off, aren't you? That's crazy. Seriously, that is so much work. I'm hitting the firewall that way. Yeah. The compressor has to come off. It has coolant lines that will be wanting to spew coolant all over the place. And then this bracket for the idler. Oh, good grief. Yeah, you deserve another one. Yes. That'd be cool too. Okay. There's certainly another coolant line. Take the tension off the belt, and I should be able to take this entire unit off. Then, I get to figure out what's going on with this. That really feels like a coolant line. I have to drain this stupid coolant. To take the valve cover off, I have to drain the coolant. Why? This is a test of patience. All I need is to just lift that up, and I'm having to work for, I don't know, it feels like hours. All right, quick gripe and get on with it. I just got the back two bolts off, and I should be able to just lift this thing off of here now. That's not coolant, that's just engine oil returning to the crankcase, so that's not too bad. And can you believe how they designed this thing? There's just not room. Different lengths. Yeah, the longer one is in the bottom. Hose right in the way of that. Well, they used a different size. I mean, why wouldn't they use 3 different sizes on the same bracket? Yeah, that bolt is trapped by this. Okay. Okay. Yes, I am second guessing my choices here. A lot of work on this old beater engine. We should now come off. Still hard. I think you have to remove the firewall to get this valve cover off. I mean, come on. Well, I just gave the valve cover a good scrub down to see if I could find any information on the injector heights. And I found nothing. I see there used to be a sticker there. That's probably where it was. Okay, I got my hands on this guy. So this is a custom tool made for this engine for adjusting the injectors. And you can't buy them new anymore, but I was able to find one used. Now, the condition, I've already looked at it a little bit. This dial indicator seems sketchy, and it's kind of not moving great.
So I want to open the indicator up and see if it just needs cleaning or what. It quickly became apparent that this indicator is not meant to be serviceable. There's no way to get it open. First of all, can't get it apart without destroying it, and I sprayed some WD-40 in there and it kind of works, but there's definitely something wrong with it. You have to twist the stem to get the dial to move, and I'm not sure I'm going to be able to use this, but it is giving me some information here. This is to calibrate it, so this is like your master injector height, and the distance between this and this lower step, this is if you're doing top dead center, that needs the heads off. I'm not doing that. The setting I need right now is on that lower step, and when I measure it, it's basically 47.7 millimeters. Yes, this thing is in metric. You adjust the injector to the proper height. It's not necessarily that. It's going to be very close to that, though. It might be 47.6 or 47.4 or 48. Basically, as you're adjusting the adjustment on the rocker arm, the injector is going to move up and down, and you can read it on this dial indicator and get it at the right height. So at least now I understand what the calibration level is, like what the baseline is, and I'm going to see if I can measure the heights of the existing injectors as they are before I take them out. I don't think I'm going to be able to get the original heights as they were because some fool decided to put them on the valve cover in the engine compartment, and of course they're no longer there. Go ahead, put it on the valve cover, but put it somewhere else too, because it's just gone now and I got nothing to go on. And no, I am not pulling the heads on this engine and doing a full engine rebuild. Not a chance. Alright, little update. I mean, this dial indicator just doesn't work. If you twist this to the right, it will move the dial, but it's very stiff and jumpy. And if you're not actively twisting it to the right, it'll just move, but the dial doesn't go with it. And I paid too much money for this as it is, so I'm going to be sending that back. However, you can do this with a regular dial indicator. This little fixture is very helpful. What I've got here is a regular dial indicator just clamped on there, and then this clamps to the top of the injector, and you put it on here, and these little spring-loaded guys go down and lock in that groove. The same way they're going to lock onto the injector. They actually lock onto the injector spring and register to that face. And on the right step, you set it to 0. So there I have a calibrated dial indicator now. I can now use this to measure the injector heights and at least see where we are before I take these things out. So you guys don't have these specialty tools, but you have one of these engines. Well, stick around to the end of the video because I have a solution for you. There, so this is going to go down and it's going to press against, we'll look at it later, but it's a spot on the injector. So you're measuring the relative height between the face of the injector and that thing at the base. So we will slide this down into position, and this little guy fits right over that injector, so there's really no way to get the dial indicator in the wrong spot. You twist those around until they hook on the spring. There, so now we're hooked on, and we're registering against the face of the injector, and I can't read it. Yeah, I'm gonna have to use my phone. The top of the injector is 13 thousandths higher than calibration, and that's because the gauge is 13 thousandths away from 0, so it means the distance is larger than what the calibration was. Take that off of there, stick it back on here, and just verify calibration is still good, and it is. Go to the next one. This would work really well if I could actually read the dial indicator. And you say, well, why don't you just turn it around? Well, I tried turning it around, but it won't get in the right position when I do that. 15 thousandths, no, 25 thousandths. 25 thousandths high. Now, I have no idea what these things are supposed to be. Maybe this is a reasonable setting. I'm just getting where they are now so that I'll have that information. So let's go to the third one. Kind of curious if we won't find a major outlier here, because this was the basically dead cylinder. This is the one that wasn't contributing anything. And a lot of people said I wasn't using the infrared thermometer correctly. It was right. I did a lot more measuring than what I just showed on camera, and it was right. Trying to get the camera centered so I don't get a bunch of parallax. So that one is markedly different. That one is 28 thousandths lower. These two were both high. The first two I checked, cylinder 1 and 3. This one is 28 thousandths low.
Well, yeah, I forgot. You're gonna have to make sure the camshaft is not pushing on that injector, John. These are in an idle position, but there's not gonna be any clearance or anything on those. But that rocker arm is being pushed. So that injector is currently firing. So we're gonna have to do some engine barring over. All right, I also came over on this side. I put all the rocker assemblies back on, torqued them down, and I'm checking the injector heights over here too. Rotate the crankshaft until the number 1 injector starts to descend just a little bit, 20 to 40 thousandths. And at that point, you can check 3, 4, 6, and 8. And then after you've done that, do the same thing for injector 6. Yeah, number 6 injector right there. And you bar the engine over until it starts descending.
And then you can check cylinders 1, 2, 5, and 7.
So I've already measured the first 4, and now I'm ready to bar the engine over until number 6 starts to descend. Looking through, I've got the dial indicator on it and I can just see it. So if it moves, I should be able to tell. So now I'm ready to check the other 4. So you've seen what I'm doing. I'm going to measure those heights and we'll bring you back. So here's my results. I rechecked all my readings. Every one of them's high. The lowest one is number 4, was 19 thousandths high. The highest one was 6 at 27. The good bank is at the bottom here, 2, 4, 6, and 8. We're 21, 19, 27, 21. The bad bank, the left side, were all 25. I don't think that would explain, that's not the reason that those cylinders aren't contributing. But I'm glad that I know where they were, so now I don't have to worry about taking the injectors out at this point. I spent entirely too much time learning about this engine that I'll never ever buy another one of. Anyway, I was thinking about pressurizing the fuel system and looking for leaks. There are 2 seals in the injector. I'll put it on screen now, but there's basically 2 O-rings, and the fuel is coming into the head right here, and there is a gallery going down the center of the head, and all the injectors have the fuel running around them in that gallery, and then it exits the head and goes back to the tank. So there's no fuel lines in here that could be leaking. It's actually part of the head. Almost certainly the leaking is going to be from those 2 seals on the injectors. If the top one's leaking, it would leak into the valve cover, and then the fuel would work its way back into the crankcase. If the bottom one's leaking, it would be leaking into the cylinder. Also, the possibility is that the injector is just like dripping or squirting fuel instead of atomizing it, and then it's going to run down the cylinder walls and get into the crankcase that way. So I thought if I pressurized it, maybe I'd see fuel coming up, and then I'd know where my leak was. But the reality is I'm going to change all these injectors anyway and replace all the seals anyway.
Basically, I decided doing a fuel pressure test was going to be a lot of work that wasn't going to change what I do, and it didn't seem worth all the trouble, so I'm skipping that.
All right, enough fooling around. Let's pull some injectors and see what's going on in here. So we've got 1, 3, 5, and 7. There it is. Just slots down over the rack. There's one O-ring that doesn't look too bad. Another O-ring that doesn't look too bad. So I can tell you right now, they used to pop test these things, took special tools that you needed to be able to supply fuel to that while pushing down on that. Nobody has those tools anymore, including Area Diesel Service, or they don't do it anymore. I'm sure they could if they really wanted to, but their recommendation was just put in new injectors. There you can see the rack. There's a gear in there, and the position of this is what determines how much fuel is injected. Like that is low fuel, and like that would be full injection. Now it doesn't move that much. I'm also suspecting that the rack movement on this side may not be enough. I'm going to end up having to look into that because the entire bank was low, but of course there was variability between the different injectors, so there might have been 2 different things going on there. It surprisingly doesn't look too bad down in there. No rust, it's pretty clean. There's a little bit of schmutz that I'll just clean out like with a cotton swab. pretty carboned up on the injector tip. These seals don't look too bad. This is cylinder 5. They don't look too bad. Injector tip looks pretty gummed up. I mean, don't get me wrong, those O-rings are hard, but they don't look as bad as I was expecting. I pretty much leave the valve covers sitting on like that all the time unless I'm actually working on it.
So this is the same thing except on the right side, so we're going to do the fast version. Worth noting that this is the side that was contributing more power, and I'll just go ahead and tell you the injectors on this side looked pretty much the same. I didn't find any smoking gun with like a cracked O-ring. They all had kind of gummed up injector tips, and the O-rings were hard but still flexible.
Yeah, I just scoped all the cylinders and talked you through it, but I didn't hit record on the scope, so it's going to be hard to edit that. So let's do it again. Let's hit record. Okay, we are recording. So in cylinder 8, I actually saw good cylinder walls. Still has crosshatch, a little bit of vertical scoring. You're going to see that, but nothing bad. Remember, on a scope, everything is very magnified. That really looks pretty good. And we turned around and looked at all the valves. They all look fine. They all look the same as this. Some carbon in there, but nothing bad. Now 6 is right near the top, and I was not really able to see anything in 6 because I can't advance. So we'll come back to that. This is 4. 4 had a fair amount of liquid in it, which I find kind of interesting. Sitting on the piston and then down between the piston and the cylinder wall. I mean, the walls look okay. See some crosshatch. Nothing terrible there, but a fair amount of oil in there. If that's oil or fuel, I'm not sure. Fair amount of liquid in there. Alright, and 2. Number 2 is closer to the top, but you can still get a look. You can see the cylinder walls, but you're kind of looking at them straight on, so you see a lot of vertical scoring. I kind of want to look at that again after moving the engine. But what little I can see, nothing major in there.
Alright, let's go to the left side of the engine.
And we'll start with cylinder 1. Cylinder 1 is right at the top. We'll come back to cylinder 1. Cylinder 3. See a little crosshatch on the walls there. And some liquid in that one too. Okay, cylinder 5. This was our dead cylinder, according to exhaust temperatures. Wow. Cross-hatching. A little vertical scoring on it, but nothing bad. I'd say compression is probably not the issue here, because that cylinder looks pretty good. You know, this one's got nothing in it. It almost looks dry. I bet you this one's not injecting, and that's the problem with that. Turning around, looking at the valves. Could be another reason to have no compression is a non-sealing valve, but the valves look reasonable. 7. 7 also looks fairly dry. Got some cross-hatching. Really doesn't look too bad.
And I barred the engine over so that I could see the other cylinders that were at the top before, and they pretty much all look the same. They all look pretty good, and many but not all have a puddle of liquid in them that I assume is diesel fuel. I think that's the cause of the diesel getting into the oil and the lower injector seals probably leaking, or the injector is just squirting raw diesel in and not atomizing.
Alright, these injectors are proving to be quite a challenge. You surprised? I'm not. The main supplier of them was Interstate McBee, and they quit making them. So basically nobody has them.
What about area diesel service? I mean, surely they could help me with this. And yeah, I used to work on these injectors all the time, but there's a hard reality here. Nobody is making the injectors and nobody is making the parts. Not for this engine. These are precision parts that are hardened and tempered to a certain Rockwell hardness. They don't have anything in stock anymore. They don't have the injectors and they don't have the parts because they've used them all that they had. And when you can't buy more, I mean, what are they going to do? Which raises a point. If Area Diesel Service can't help you with your diesel engine, maybe it's time for a new engine.
Yeah, I'm still scratching my head. There's some on eBay, but you know how eBay goes. I really want a way to test them, because if I get some off eBay, I want to know that they're atomizing before I just put them in and hope. And I can't even find the pop testers that they used to have for these. See, it's not like your modern day injectors, because those you use an external pump and you pump through a fuel line to the injector and you look for opening pressure and you can see it when you hit a high enough PSI, it'll inject. But this doesn't have an incoming fuel line. It has a screen and a gallery that is around it that is full of fuel, and then the pump is inside. So basically you have to supply fuel to it and then forcefully push that down and see if it atomizes. I think maybe I can build something that will at least allow me to get an idea what these are doing. And it'd be nice to see what these were doing. It would also be nice to see what any that I end up putting in from eBay are doing. So I need to make a fuel gallery that goes around this thing, and I've got a seal there and a seal there, and I need to measure the bore down that this lives in so that I can machine basically the same size thing that will go over that. So we're reaching down in here with a bore gauge, 1.108. Upper one I believe is bigger, 1.222. So basically this is what I'm making. One end needs to be 1.108 and the other end needs to be 1.222. So I'll do 1.108 the whole length, and then we will back off and leave that alone. We'll do the rest of it to 222, and then I'm going to have to reach in and carve out the gallery in the center for the fuel. These are where the O-rings are going to be sealing on the injector to keep the fuel into our little gallery that we're going to make here. So that was a 1-inch bit. We need to go to 1.108. So I'm at 1.082. We are going to measure with a bore gauge, get as accurate as we can. At 1.082. So we got 1.095. It says 1.102. And same. Yep. Okay, so now that is the deep part. So we only need to go 1.25 inches in and measure and bore to 1.222. So I need to measure so that I only go to 1.25 inches and then I stop. I'm not looking at 1.25 inches to the thousandth, but this will be pretty darn accurate. So I'm just going to touch the front, and we're going to set an indicator on the ways and zero it. There's 100, 2, 3, 4, 5, 6, 7, 8. We'll stop there, and I'm going to set it to 0 again. There's 9, there's an inch, 1.1, 1.2, 5. 1.25 inches. Now we'll zero again. It is 1.25 inches deep on the part. When the dial indicator hits 0, we know we're good. That's deep enough. So now I'm going to bore the rest of it to 1.222. And I'm just watching the dial indicator as it gets close to hitting the carriage. I saw it was almost to 0. There at 0. Come out. And repeat. That's 1.14, so I can do 50 more. Look at that, 1.222. Now's the tricky part. I need to reach past, so it's kind of like this. I need to reach past this 1.222, which continues for 450 thousandths, and then I need to bore out the rest of that. It needs to be bigger enough for fuel to flow around, because we're going to put the injector down in there, and yeah, fuel needs to be able to get around that area. So here's the plan. I've got this little grooving tool, and that's going to allow me to reach inside and make a big groove. I'll just have to do really light cuts and go back and forth. I have to leave that alone, and I have to leave the far side alone. So I've got my 2 dial indicators set here. This one, when it gets to 0, right there. So that is the far side of my fuel gallery, and beyond that is where the O-ring is going to be sealing, so I'll leave that alone. And then when I start going the other way, I've got a dial indicator here, and we put it on 0. So that is the near side of our fuel gallery. So I'm going to go in, touch off. I'll probably do like 10 thousandths a pass and just go back and forth. So I'm watching for that to hit, and then the dial will start to go around to the 0. Advance 10. Go again. That makes 100 thousandths. I think that's probably going to be enough. This injector should fit in here with a nice snug fit on those O-rings. That seems really good. Okay. Now I just need to tap into that so that I can put fuel in there. I have this little bottle with a valve and a hose coming out of the bottom of it. This is for actually dispensing cutting oil on my mag drill. The end of this tube goes to this guy, and it has a sealing washer on it, so I put a flat right there. So then that's going to plug in there, and I want to be able to bleed the air, so I put a hole in the other side, and I'm just going to try to stop it off with a stopper once I get fuel coming out. If that doesn't work, I'll actually thread a plug and thread it in. I just don't know when I start trying to pump it if there's going to be some back pressure that'll pop that out of there. I don't know. The injector will go in, and I can supply it fuel now without it leaking all over the place. And now I just need a way to push this down quickly and forcefully. Alright, we're starting out with injector 2. That's gonna work. It just shot. I didn't think this was gonna work. Fuel going in. See, now the air is stopping it. So we take out our plug on the other side and let it slowly run until we get some diesel. It's running diesel now. That's wild that that's working. Okay, so this is injector 2. So this is from the right bank, and this was the side that seemed to be working well. And I see pretty good atomization there. I'm going to rotate it a little bit so I can see the other side as well. Yeah, I don't see anything there that doesn't look right. And of course that's what I would expect, because that side seemed to be working well. Alright, we're going in with number 4. I want to just verify that all the good ones seem to be working as expected, and then I'm hoping we're going to get the smoking gun answer with the injectors on the bad side. Yep. This is cylinder 1. This one was working, but definitely not as well. Oh, that's interesting. See it dripping off the end? So it's like one of the nozzles is just making drips. And this is cylinder 3. I mean, the streams are more concentrated, I think, but it doesn't look that bad. And just because I'm a jerk, we're going to 7 next. I'm saving the worst for last. Number 5 was the apparently dead cylinder. That's going to be the last one we check. So far I'm kind of disappointed. I was really hoping I would see a drastic difference, but maybe I'm just expecting too much. Full fuel position. See what we get. Whoa. Am I missing something here? I can't push it down. There it goes. Wow, that was stuck. Oh. Yeah, there's definitely something wrong with this one. I don't know if you just saw it. It shot just solid streams of fuel. It was stuck. Like all the holes aren't even shooting. Yeah, I see a solid stream going that way. I think there's one going back. But there's supposed to be 5 holes on this thing. That solid stream right there. Nice. That would definitely do it. Definitely something wrong with that injector.
And now we go to injector 5. This was the dead cylinder that had no increase in exhaust temperature even after running for several minutes.
Let's see what we get with this one. How about nothing? I'm in the full fuel position. Boy, that's gratifying.
I see it's pushed air back into the fuel line, so I bleed the diesel again.
That is a dead injector. That explains a few things. Let's see if I can hit it faster. Nada. You know, actually, I think it did kind of give me my answer. I definitely saw reduced injection on the bad side. I saw more solid streams where fuel would be hitting the cylinder wall and running down and pooling in the cylinder. I think getting these injectors sorted out will certainly make a big difference. Check this out. Somebody sent me, this is a snap-on diesel timing gauge for this engine with a functional dial indicator. The gauge block, this one works a little different. This is a magnet. It just clicks on there. Thank you so much. I'm definitely putting that to work. A Snap-on 8.2 liter diesel tune-up set. So again, for this engine, looks like it's got the feeler gauges for the exhaust and the intake. And honestly, I'm not sure what the rest of this stuff is for. 216. I might have to do some internet searching to figure out what I'm supposed to do with these. Thank you. When I get old and I'm not using my tools anymore, I'm going to be doing some of this too. Handing them off to people that will use them. So I'm curious about these injectors. This is injector 8, and I think they're pretty easy to come apart. I think you just have to push it in a little bit and twist. Yeah, and then that comes off. Hey, look at that. So simple. So this is the plunger, and this gets twisted. It has a helix right there. So depending on its rotational position, changes what's happening as far as the metering of the fuel. I'm not exactly sure how just yet, but twisting this is what moving the fuel rack does. Spring just comes off. At this point, I think you've got to take the nut off. Oh, look at that, just pops off. It's just sitting there. See down in there, there's a gear, and right there is the rack that turns that gear. So I've got it held in the soft jaws. Hopefully I don't have to wrench on it too hard here. I expected it to break loose down there, but it broke loose up higher. Let's take that back over to the bench in case stuff starts falling out. Yeah, so this is a check valve. Flow in this direction and obviously not back. And then there's a spring that holds that against there. What else do we have in here? I believe there's a lot going on in this thing. And then I believe you can drive out the spray tip. This is a needle valve. Okay, what about this side? There's that gear. And there's the rack. So this plunger, that's basically your pump. I can feel that is a very precise fit. Interesting. Okay, well, so what's happening here, this hole is exposed at different points depending on the rotation here. So fuel is in there, and then this thing gets pushed down and it blocks that hole. Now at this point, there's fuel trapped in this cylinder, and it's going to pump until the hole is uncovered and relieves the pressure. I'm pretty sure that's right. So when the pressure is relieved is determined by what position it's in, because if you're at the lower point of that slant there, then it's going to relieve the pressure sooner. If you're at the higher point, it's going to give it a full stroke. So kind of the difference between your metering is the high point of that ramp and the low point. I don't know if I explained that well, but it's all about when that hole gets covered and uncovered. Determines how much fuel is getting pumped. So I'm going to open up another injector. I want to see why the dead injector is dead, if I can. So let's get injector 5. Take a look at that one. I see a lot of scoring on this plunger. Hopefully you guys can see that. That one's pretty scored up. Let me grab the one off the good injector. It looks nice and smooth. So I suspect this one is probably just not able to build enough pressure to overcome the opening pressure of the check valve, and it just doesn't inject anything. Oh yeah, that feels like kind of crunchy. It doesn't have the same smooth feel at all that the other one does. In fact, I'd go so far as to say it feels a little bit sloppy. So yeah, I don't think that's building any pressure is the problem. Okay. Now, how am I going to get new injectors? I found a company in California that actually will rebuild these. Talked to the guy on the phone. He's been a mechanic a very long time, no surprise. The old guys are the ones that are still working on these.
and he's got the parts to rebuild it. So I just need to send these to him. Of course, it's going to take a while. But if he needs to replace the plungers or the barrel or the spray tips or whatever, he's got all that stuff. So yeah, I'm going to get basically new injectors. They do a total disassembly, they clean everything, replace the parts that are out of spec, and then do a testing on it. And I'm going to get rebuilt injectors back, working just like new. So let's get these things packaged up and on the way to California. All right, that's going off to California. Wow. Just to let you know, getting these injectors was not easy, and the guy who did these is 78 years old, and he is still doing them. He still has the parts to do all the rebuilds. He's got all the testing equipment to calibrate them, to test them. There's still a lot of these engines out there, and people are still using them, but the ability to fix them is going away rapidly. So I would say if you want to get your engine running right, you better do it soon, because this is one of the few guys left that can actually deal with these injectors. My next option was just going to be to buy the crapshoot on eBay. You know, there's some for sale, and they're not cheap. They're like $200 a piece kind of thing, and you just never know what you're going to get on there. Here, I'm quite confident that we have appropriate rebuilt injectors from somebody who knows what they're doing. He tested them all, and they're all functioning as they should. Yeah, that looks like that's a new part there. That doesn't look like it was just cleaned. He did a full teardown, ultrasonically cleaned everything, and then did a reassembly replacing what parts need to be replaced. He noted the one that wasn't injecting at all, it needed like a new plunger and barrel. I think he might have done a couple new nozzles, I'm not sure. And he charged me $85 a piece plus shipping. Very, very reasonable. I'm real happy with this. By far the cheapest solution and probably the best solution. I can't help myself. I want to see if I can see any difference in my little test setup with one of the rebuilt ones compared to what we started with. It does seem different to me. I'll have to review the footage to really see, but it seems like it's a much stronger, more sudden burst. Before it seemed a little more sloppy. It would kind of... And this is more like a pop. I also noticed that the old injectors were spraying out a lot more fuel than the rebuilt one. Too much fuel means an incomplete burn, lots of smoking, and fuel running down the cylinder walls into the engine oil. So hopefully we're going to see a difference in how it runs. Alright, so I know this question is going to come up. Why am I not checking compression on this thing? Well, there's several reasons. To check compression, I would need to attach a gauge to the cylinder and then crank the engine. So right now to crank the engine, I'd have to hook the wires back up to the starter. I'd have to deal with all these loose belts. I'd have to somehow turn the fuel pump off, because if I let it crank right now, it's going to be pumping fuel into this gallery here that feeds the injectors, and it's just going to flood all the cylinders with fuel. I would need to machine something that is injector shaped, has the two seals, goes down into the cylinder, but also would allow me to hook a gauge to it. I'd have to be able to clamp it down, and it would also introduce additional dead space, so it would give me falsely low readings. Put all that together, the reality is there's zero chance I'm rebuilding this engine. If this thing has compression so bad that it won't run, then I'm scrapping this engine and we're getting a different engine. I know it'll run because it ran when I started this job, so it's just too much work, too much trouble for no return. I am excited to get these injectors back in their holes though. See, as you drop them in, you just have to line up the rack there with that little pin. So the governor pushes on this to adjust the fuel for all of the cylinders. Here I'm putting the bolts into the hold down clamps. And then I get them all torqued to spec. And now the rocker arm assemblies.
And I imagine some people are thinking, while you're there, you should tighten those head bolts. Well, I thought about it, but I don't think that's a great idea on this engine. That's the weak link of these engines, is the head gaskets. They lose their seal and they leak because there's just not enough clamping force in the design. And I think fooling with that at this point is more likely to cause problems than to help. So I'm leaving them alone. These are 34 to 39, so I'm doing 36 foot-pounds. All right, I'm gonna leave this like this until I get the other side up to this point. Okay, so now we need to do our injector heights, and I'm also going to adjust the valves. Certainly that could affect the power output, but poorly adjusted valves isn't going to put diesel fuel into the engine oil. So that wasn't my primary problem, but I'm here, we're adjusting the valves. So I'm going to get the engine into the position it wants me to do the first 4 cylinders, and then we'll do the others. So I got a wrench on the crankshaft pulley here. So that just started to move. Okay, so number 1 is injecting right now, and according to our manual, we can now do the injector heights on 3, 4, 6, and 8, and then it also tells us which valves. So let's do our injector heights first. I'm just resetting these to where they were. So 3's here. The others that I'm going to be doing are on the other side of the engine. This new dial indicator is so much nicer than what I was doing. But what I measured, I was doing in thousandths because that was the dial indicator I had. And cylinder 3 was 25 thousandths high. That means 25 thousandths above calibration. Well, that worked out to 0.635 above calibration in millimeters, because the calibration on this gauge is 47.7. That means this gauge needs to read 48.33. And this one is at 48.4. Interesting. Okay. Right there. Nice. It stayed there. So that's 48.33. Excellent. Yeah, sometimes adjustments like this are really obnoxious and they won't stay put, but this seemed to stay right where I left it. So that's good.
So right now the injector on cylinder 1 is being depressed. That means it's on its compression stroke, and I can adjust the valves on that cylinder.
So the intake is supposed to be 12, and that actually feels pretty good. Might be a touch loose. Let's see how this one feels. So the exhaust is supposed to be 14, and that won't go in there. Yeah, 12 is tight too, so that one's definitely tight.
Alright, 8 sets of valves to adjust on this engine. You back off the jam nuts, and this is a 12 thousandths gauge, and that's on the intake valve. You tighten down the adjustment screw until you just have just a little bit of drag against the right feeler gauge, and then tighten down the jam nut. Now sometimes when you tighten the jam nut, it'll change your reading, so you gotta go back and check again.
Is that gonna move it? I think that's okay.
Alright, now to the exhaust valve. This one's 14 thousandths. And just getting the right amount of drag and then tightening the jam nut.
That one's still a little loose.
So in fine tuning, you can sometimes tighten the adjustment screw and the jam nut at the same time.
Pretty close. Yeah, I like that.
We'll be borrowing over the engine before we do the other valves.
Alright, so I've adjusted that, and that. Let's go to the other side and do those injector heights. Alright, so now I can do the injector heights on 4, 6, and 8. Just under 48.3. Let me see what I need on this one. 48.18.
Can you see that dial indicator there? No? That hose is in your way? Well, welcome to my world.
48.18. That is correct. Cylinder 6 is 48.39. Let me try to give you guys a better view. Cylinder 6. I bet if I knew which injectors were which and could have put them back in the same hole, I might have been able to have these pretty on. But after he cleaned them and everything, I have no way of knowing which one was where. Because I bet you that's what's making the difference here, is more just a different injector being in there. But anyway. Plug right there. I screwed that up. That'll do. Looks like 48.24. That one's supposed to be 48.23. All right, I'm here. It's really close, but it is something I can change, so let's do it.
And here's the view you get of me adjusting that one. There's just no room for a camera in there while I'm working.
Okay, so I got all those injector heights done. The next valve I can do is this one. I need to spin the engine 90 degrees for that.
So I'm barring the engine over and you can see the injector start to depress. That means it's on the compression stroke, and that's a perfect time to adjust the valves. I'm not going to bore you showing this again. It's the same on each cylinder. You loosen the jam nuts, you do the adjustment until you get good drag, and then you tighten them back down. Rotate the engine to the next compression cylinder and repeat.
Because the yeah, that one's tight. But the intake here feels loose, and it is. The exhaust feels tight, and it is. It won't go in there. You know, the problem with working on an engine like this that I don't have a lot of confidence in, and I know is just destined to blow up one day and get scrapped. You do all this work, and I may actually get this thing running better, but better might mean higher combustion pressures and more power, and sooner to have a catastrophic failure like a head gasket. Because if the heads have to come off, this thing's going to the scrap heap. So hopefully I won't get this thing running so well that it blows itself up. I can now do injector timing on 1, 2, 5, and 7. 2 is the only one over here that I haven't done. And in between, it is good to put this back on this gauge block and calibrate it so that it is set for exactly 47.7 millimeters. It's supposed to be 48.23. And I'm at 48.36. 48.23. Right there where you can't see it. 48.23. 48.39. And it's supposed to be 48.33.
So I think you guys get the point on the procedure for doing the injector heights. Here in the middle I bump it, so I recalibrate it. And I go ahead and adjust all the remaining injector heights to exactly where they were, including this one that required some 4-letter words.
Yeah, as far as I can see that gauge, I think that's right. It's close. 4 more cylinders, valves to do, and then we're done in here. I don't think I found a single one that was just right. Every single thing needs adjusted, but I guess that's to be expected. Nobody's been in here for a few decades. Adjusted all the valves, and we have adjusted all the injectors. And I feel pretty good about it. You know, when valves are loose, they don't open as wide, and you're going to get less intake and obviously less time for exhaust. They don't open as wide. They also don't open as long. So you're just kind of choking down your engine when the valves are loose. When they're too tight, they don't close all the way, and you don't get good compression. Yeah, they all needed to be adjusted. So everything should be running more efficiently now, and obviously with the new injectors, hopefully we're going to see a huge difference. And not be dumping diesel fuel into the engine oil. That's the primary thing. Quitting time today. We're just going to cover up and we'll get back to it tomorrow.
So what I need to do now is make sure that this mechanical fuel system is being controlled properly. And it's somewhat complicated, and at first I was really kind of reluctant to go through all the studying and learning on how this thing works and how to adjust it correctly. I felt like I was wasting my time on this engine, but This procedure is very similar to the two-stroke Detroits that are better engines. I don't own one, but one day I might. It'll also be useful for other people out there seeing this that own one of the two-strokes and the 8.2 if you want to keep your 8.2 going. For some reason, you could be an idiot like me. So basically how this fuel system works, this is the governor. When you press the throttle, the pedal, you're doing this, and that sends, there's a control rod that's coming through this from the governor, and you can see it sticking out right there. It goes to that lever, which then actuates this control shaft here. And this shaft is connected to each injector. That little rod that controls the amount of fuel is being actuated. And obviously they all need to do exactly the same thing, and that's the key. This shaft rotates. I hope you guys can see that. And it is connected right there to each injector rack. I'll put arrows on screen. Right there. When I push the lever, you can see that rack moving. So the key here is they all need to do exactly the same thing. All four on this side, all four on the other side. So whatever throttle position the foot pedal is in needs to put all of those injectors in the exact same fuel position so all the cylinders are doing equal work. And that certainly could have been part of the problem with my imbalance when I was checking the exhaust temperatures, because if the fuel rack is not adjusted right, even if the injectors are working correctly, they're still not going to be injecting the same amount of fuel. So we need to do what's called running the rack on the old Detroits. Now it's a little different with the 8.2, but it's the same basic procedure. So the first step, I need to loosen this, an 8mm 12 point, which was hard for me to find. Most of the little stuff is all 6 point, but this wrench has a 12 point end. That is uncoupling the governor from the control shaft. And that's going to allow, so now this shaft is much easier to spin because I don't have, the governor isn't involved anymore. I'm going straight from the service manual and everything I'm doing here. And the first thing it wants me to do is this hex head right here. This is the linkage between the control shaft and the rack on cylinder 1. And this one is not adjustable. This is a fixed connection. So it just wants to make sure that that's tight. And it actually wasn't tight. So now the control rod is loose, and it wants me to put it in full fuel position. The very nice retired mechanic who sent me the tune-up kit and the dial indicator and everything, I've forgotten your name, sorry, but thank you so much. It has the little tools that I'm supposed to use for this. This you could easily do a hack, but you just need a little pin that'll fit in this hole right on the end of the control rod, and then you want to put a little bit of spring tension on it just to keep it in the full fuel position. So this is stretchy. You could use, most anything for that. So that's keeping that rod held at full fuel. Now obviously we're going to go on and work on the governor. They have a sequence you go through in the manual. Since I've uncoupled this from the governor, I absolutely have to go into the governor now and make sure everything's going to be right there. Because otherwise, if I just screw that back down, actually if I screw it down right now, this thing is going to be at full fuel position when the governor is saying it should be idling, which means you're going to have a runaway. Be careful if you're working on yours. You have to absolutely make sure everything is working correctly and that it goes back to the no fuel position on its own before you try starting this thing, or you're going to be out an engine, which may not be the worst thing in the world. This is all very hard to film because I'm working kind of up away from myself. This is all way back in this engine bay and I'm kind of working back towards me. So now we should have this injector 1 at the full fuel position. Yeah, so it is bottomed out there. It wasn't before when I was trying to do this, so it's probably a good sign. I don't think my adjustments were very good. So what I'm doing is pushing on this with a screwdriver and verifying that it's bottomed out. All the way in is the full fuel position. So that is kind of like the master injector at this point. That one is at full fuel, so I need to make the other 3 on this bank in the exact same place right now. That right there, that's the end of the injector rack. This is the adjusting screw. So I turn that in just until it bottoms, and that's where you want it to be. Right there.
I'm just kind of getting a feel on how much tension there is on this one. Like how easily does that wiggle. That might be a little tighter. Seems about the same. So those two are both hitting the full fuel position at the same time. And what's crazy is I can just turn this with my hand, and this is supposed to stay in position when this thing's running.
And now I'm just pushing on all three of them to make sure they have about the same amount of tension on them.
Push down on that one, it sticks. But
I got them all working together pretty well, or so I thought.
I think I see a problem. For some reason, number 5, the one that wants to stick when I push on it, also is not as far down. It's like it's hitting something that it shouldn't be hitting. And I think it is. This injector here is almost at the bottom of that machine section there. And that's where all of them are. Number 1 is also right near the bottom of that. Number 5, when 5 is sticking again because I pushed on it. Five is not at the bottom. It's definitely up higher. Because I think it's hitting something that is preventing the injector from going to full open. Can't have that. That cylinder won't be getting enough fuel. It looks like it's hitting the injector clamp, which I think I can probably just move to the side. And I think that's also why it's sticking. See it right there? The injector rack is hitting that. So let me loosen off that injector and just rotate that clamp over to the left a little bit. Should do it. Alright, I've got it snugged down and it definitely has clearance. So we got our clearance. Let's torque this thing back down.
So I torqued the injector, I put the rocker arm assembly back on and torqued that to spec. And then I couldn't help myself. I went ahead and rechecked the injector height and the valves, but they were all fine. And now we're back where we were. I can adjust that injector so that it's at full fuel just like the other ones.
Okay, now when I push down on it, yeah, it doesn't stick anymore. Give it a good hard push down. Yep, that was a problem. Glad I got that. Would stink to find that out after getting it all back together, that's for sure.
So to the other side, we start out loosening that 12-point bolt that couples the governor with the control rod. And then the pin with the bungee goes in the far side of this control rod.
4 seems good. Definitely cylinder 6 has too much slack. But just to make sure, I guess what can happen is if one of them's hitting too soon, it won't let number 1, or this is number 2 now, but it won't let the master
go to the actual full fuel position.
Yeah, it was pushing on it. I just saw number 1 drop down when I backed that one off. So these were not in sync. So I've backed them all off. Number 1, 100% is the one that's hitting. I'm saying number 1. The first one, which is cylinder number 2. Yeah, I don't know if I can film this. You guys are in the way. I'm hitting my head. There's no room. I'm going to do the same thing on this side I did on the other side, and we'll bring you back. So I've got all of them moving well together. Next step in our lovely procedure is going to be this governor assembly. It needs me to take the cover off of that. So this is the fuel shutoff solenoid. I'm going to need to take this off anyway later in this procedure, so we're going to just take it off now, get it out of our way. And it defaults to fuel shutoff, and then when you energize these by turning the key on, that gets pulled back and allows the truck to run. Yeah, I'll be honest, I didn't really want to get into this, but I don't see any way around it. And it's one of those things, you're here doing all this work. It really does pay to make sure that the governor is set correctly and the engine is running from correct idle speed to correct wide open speed. Okay, I'm going to put this back in correctly. Take it off. This guy here needs to line up with a little fork in there. The throttle cable was hooked to that basically, and the fuel shutoff solenoid was pushing on this. So that is off, and that's full fuel. It says place a tool J29646A between the low speed spring cap and the high speed spring plunger. Set the idle gap to 5.5 millimeters or 0.216 inches using the gap adjusting screw, figure 4. Well, there's figure 4. You can't see a darn thing as to like where they're putting it. See that? The gentleman who sent me these tools, though, this is the tool. You can see it says 0.216, and I measured it. That's the dimensions of it. And it has that curve on the end, which I'm taking as a clue that it must go right there. And you can see it's loose, so it's not in adjustment. Because that curve does match that plunger. There's really nowhere else that I can see that that curve would make sense. It doesn't make sense on the bigger diameters. See, it doesn't fit. But it does fit right there. So it's got to be that. And it's too loose. I think that's it. And that's got to be right. Why else would they put that curve on there? Somebody tell me if I'm wrong, please. So the next step is I need to take this plug out and put a bolt in there to reduce that gap to basically nothing. Yeah, that would be the full fuel position is what we're going to be doing. So now it wants me to put a 3/8 24 bolt, 3 inches long, has to have at least 1.5 inches of threads, basically close that gap. That sets a position in the government. That sets a position in the governor that we can then tie the governor back to the fuel racks at that position. So I've got bolts wandering around this shop in several different places, but I've looked. I do not have a 3/8 24 anywhere, including on my threaded rod. What I do have is a 3/8 bolt, that's 3/8 16, and a tap and die set. So let's make it happen. Yeah, I need one of those giant bolt assortment sets like Diesel Creek has, but I don't know. Might be a while. That's tap magic. Can't really read it anymore. 3/8 24 die. Said at least 1.5 inches of threads, and I'm past that, so should be good. So this thread's in here. Basically, I'm going to keep threading until this gap is less than 3/1000ths, and I've got a 2/1000ths gauge right here, so if it catches this, we're good. There, it just grabbed it. Well, almost. There, it's got it. Okay, that's pretty much where you want it, or exactly where you want it. And now we can go to the next step. We put the governor cover back on. So I'm making sure that that right there lines up in this fork right here. All right, it says go ahead and torque these down, so I'll do it. Apparently we're not going back in here. Okay, so the fuel shutoff solenoid would be pushing right in here and do that. So that is the 0 fuel position. And right now it wants me to secure it into a full fuel position. I can use these again. Okay, it wants me to put this rack in the full fuel position, and I see what's going to happen now. Pretty basic, really. You've got the governor in full fuel, you've got the rack in full fuel, and now we can tighten that bolt, right? That's what it says. And it also wants me to kind of push it this way as I'm tightening. Pretty tight. Let's see what happens when we move. That is no throttle. and that is full throttle. And I have to say, that is a lot more movement than this thing had before. I hope you guys can see that. Okay, now we're going to do the same thing on the other side. Alright, my lapel mic died, so hopefully the wind noise isn't too bad, but I've got the little bungee on again. So the rack is locked at full fuel, the governor is locked at full fuel, so we are okay to tighten this guy. That would be a lot easier with a socket, but I do not have an 8mm 12-point socket. Wouldn't you believe it? Probably have one somewhere. I couldn't find it though. Everything feels good. It's moving freely.
This is the amount of rack movement that I had when I first pulled the valve cover off. And here's now. That's a big difference.
Alright, I did that wrong. I get to reset these racks again. Instructions aren't the best, so when it said go to full fuel on the governor, to me that's full fuel, but there's a yield spring at the end, and that is to prevent the governor from pushing too hard on the injectors themselves. And what you're supposed to do at full fuel is go to the yield spring and then let it go right there. That's where I needed to set these. Yeah, I've got it basically set too tight right now.
So no big deal. I loosened off both control rods and then set them to that position on the governor speed control on both sides. Just don't make that same mistake if you're working on yours.
Yeah, and this is where you want to confirm all those injectors are moving before you put this thing back together and go to start it. Because if you have the racks tightened down wrong and it can't get out of a full fuel or a fuel position, it's not going to turn off and could potentially run away. Yeah, the manual's instructions leave a little bit to be desired. Because it keeps saying, put it in full fuel position. What it means is, put it there. And it says like, go to idle and go to full fuel position. If there's any injector movement, then redo it. Well, of course there's going to be injector movement. That's the whole point. What it means is once it's here, if you can reach down and wiggle this rack, not the rack, if you can wiggle the control rod or push on the injector racks like we did before and there's movement, then you need to redo it. When the governor speed control is at that position, all the racks on both sides are exactly at full fuel. That's your goal. I think they could have described this in the manual so much easier to make it a lot more doable. Trying to sort through their explanations of just do this, act like a monkey, don't understand what you're doing, just makes it so darn difficult, and no pictures that are worth a darn. Anyway, I'll quit griping. We're done with this step.
There are some more adjustments to be done, but you do those with the engine running, and it's going to be a while before that happens. So I'm good to take this bolt out and then put the plug back in.
So it seems like that 3/8 24 bolt ought to be part of this kit, but it turns out it fits in there, so I'm going to keep it there. So now with that bolt removed, yeah, that returns to the no throttle position on its own, like it should. Now we can put this guy in. Get our wires plugged back in. That is all the way. That's about where it should go, which is right at like 90 degrees. And I'm going to go press the throttle, and I guess I'm going to check on the video and see if it goes to the same spot.
Hey, that'll work.
Okay, we're actually done. We're actually at the point where we can start putting things back together. First thing I want to do is get these valve covers sealed up. It actually says in the manual to RTV the gasket to the valve cover. And I think they're just using the RTV as glue. I mean, it shouldn't need that to seal. Yeah, I'm going to go ahead and do that.
I got the valve cover gaskets from Area Diesel. Thanks, guys.
Now I want it to stick to that side. I don't want it to stick to the other side. So I'm going to put a little bit of grease on that. Well, wouldn't you know it, that bolt snapped off. So now I'm trying to drill it out with a left-hand drill bit. Ooh, I think it just moved. Well, at least it came out. Alright, that's not a real bolt, but it's what I have right now, so I'm just going to leave it like that. It's pretty tight. What are you going to do with this old pig? Okay, valve covers are back on with gaskets. Hopefully they won't leak. Now it's just a matter of putting this old pig back together.
The next day.
I have a problem and I have to go back in. It's not too bad, but I haven't started putting everything back together, and now is the time to do it. When I was adjusting each injector, all I had to do was put a socket on that adjustment screw and I could turn it. And there's no lock nut, there's no set screw, there's nothing to hold it there. There's a little bit of spring tension on it. I just don't trust that that's going to stay put. So I'm going to go back in and I'm going to put some Loctite. There's only 3 per side. Let's get her done. Alright, so here's the bolt I'm talking about. That's my adjustment, that's where it belongs. Is turn it by hand. Like there's nothing holding it there. So there's one turnout.
So I thought about this when I was working on these, but then I forgot before I started putting it back together. With how much work it is to even get to these on this truck, I just didn't want to leave them like this and have them vibrate themselves out of adjustment shortly after I finished the job. So I did my best to count the number of turns out to try to put it right back into the same position. But it turns out that didn't work very well, and I end up having to do each individual injector adjustment again, but now that I've done it, it's really not that big of a deal. Basically, I screw it back in until it matches the first injector on that rack.
I got both sides done. I'll be able to sleep better now, but I learned something here. In order to do this, I had to put that bolt back in and take the shutoff solenoid out because the racks wouldn't move, and I needed to verify that everything was at the full fuel position. So remember that time when I was telling you, like, wow, the racks move so much now when they didn't before? Well, if I was checking before without that bolt in or with the fuel shutoff solenoid still installed, then that's not really a valid test.
You can see here how much the rack moves right now.
So yeah, let me pull this bolt out of here. And now, look at that. The rack doesn't move. I didn't really take the time to study the governor entirely, but if the engine's not running, you're not going to get rack movement, I think. Or I screwed something up and this thing's not going to start. Yeah, there you go. Now it's moving more like it did the first time when I checked. So I think that's more a function of the governor. And that doesn't mean that those were totally wrong before. The important thing is those injectors are defaulting. They are in a low fuel position. Full fuel would be all the way down here, so we are not going to get a runaway.
Alright, let's start putting this thing back together finally.
So this guy goes on there next, actually like this. But I think it needs a new gasket. And I wasn't able to locate that gasket, so we're going to have to make something. I'm going to try the Estonian method of gasket making. You guys know what I'm talking about. At least some of you do. Ants pants. Pretty fast. I think it's still worth doing the hole punches for me. This is a pretty thick piece of gasket though. It doesn't cut that easy. Say that's gonna work. And I remember this one needs to go into the bracket because that line traps it. That one is that one. That's right. Multiple size bolts on this bracket. I gotta do something with these wires here. So I cut one of these open just to make sure that it's nothing more than a connection. And it is, it's just a connection. Silly diode or fusible link or something in there.
And sometimes it's nice to have a break from all the chatter, so I'm going to shut up for a bit. Well, it wasn't fun, but it is back together. This wire went there because past John told me so. Let's see if I can remember how this hard line went in here. I know I bent that out of the way. And here's the valve cover breather. There's one of these on each side. But it's not cooperating. Grief. I should have done this a little earlier. What's going on there? Alright, you guys are in the way. Yeah, I got it. Once I got your fat head out of the way, it wasn't that hard. This is the lifting hook and the support bracket for the compressor. Okay, so I zip-tied that, zip-tied that. These back here all seem pretty good like they are. And then I also put some hose protection on this. Alright, this side is done. We are back on the right side, and this side is significantly easier. I need to put this breather on, and then basically I need to put the alternator bracket and everything back together. And that's it. I don't have to disconnect clutches and starters. Okay, truck is well and truly back together. So before I try to start this thing, I took this cover off right here. That is an adjustment for the idle. I was messing with it, thinking it was something else. Yeah, so this thing may not want to idle like it did. The other obvious issue is I just had all the injectors out. The gallery in the head is empty right now. So that fuel pump has a lot of work to do.
and I don't know how much cranking it's going to take to get fuel to these injectors. There's no primer pump on this thing. The only thing I could do is pump fuel with an auxiliary fuel pump. Something I could do, but I'd like to avoid it. Let's see if we can crank it over and make it start. I haven't had the battery on the charger, so it might just kill the battery, and that'll be the end of that.
If there is a good thing to say about this engine, it does like to run. No bleeding, no primer pump, no glow plugs. It just starts.
Okay. Well, how about that? Still runs. No runaway. That would have really stunk if it just took off. Yeah. First inclination, it sounded a little different to me, like a little rough, but it might just be that I'm firing on all cylinders now. One thing I did notice, it didn't smoke. This thing has always smoked like crazy. So that's awesome. I do want to do my exhaust manifold temperature testing again, but it is late in the day right now and I am tired. It is 6:41 p.m. I don't know about you guys, but when you get that deep into an engine and then you put it all back together and you go to start it, there's always that little nagging doubt. What did I forget? Is it going to run or did I ruin it? This thing, with all the stuff I was trying to figure out with the injectors and everything, let's just say that that anxiety was real and I think well founded. I thought it would run, but I really wasn't sure. It runs. So now we're going to do our governor adjustments, and I'm doing this exactly as it's laid out in the manual. The distance from here to that face is the high-speed adjustment, and that's a lock nut there. And in my new little tune-up kit, thank you again, there is a special socket for loosening that lock nut, so we'll get to that. This is called the buffer screw. I guess this prevents some cycling or something when the governor starts hunting, and I've already got that jam nut backed off. Until 15 millimeters of threads is past the lock nut, which we're not quite there. Yeah, we're good there. Wants me to measure, but there's no room to measure. The calipers won't go on there. But it wants me to back this idle speed out until at least 8.75 or 5/8 of an inch is past the lock nut. I'm just going to eyeball it. Yeah, it looks good. Here to there is supposed to be 41.4.
But my calipers won't fit in there to measure it. But this will.
Alright, so here's the setup. First I'm going to be adjusting the idle speed, that screw right there. I need to get it to 700 RPM. Now checking the RPM on this thing isn't so easy. It'd be really easy if I knew the ratio to the alternator, but you could also get some belt slip, and I don't know that ratio. It doesn't say anything in the manual, because why would it? That's the crankshaft pulley down there, which I'm not reaching my hand in there while it's running, but I think from right here, I think I can actually check that RPM. Cleaned off the balancer there on the pulley and put a piece of reflective tape, which hopefully will stay on. So right down here like this is how I'm going to be checking that RPM, and then I'll be doing my adjustments there. Let's start her up. Right around 600.
So my fat hand's right in your way, but I'm just slowly turning that screw in and watching the RPM as well as listening to the engine.
Okay, so you could kind of hear it like going up and down a little bit. I got it centered right around 700, so I'm going to tighten it there. Next step is start it again, and then I'm going to do the throttle here. and check the RPM, and I want it to be a maximum of 3,000. That's when the governor should kick in and prevent any more fuel from being added. Alright, well, this is not easy. Holding that thing here and keeping it pointed just right while you're also manipulating the throttle over there, and having this belt right in your face with this rusty fan throwing little bits of rust on you. It doesn't exactly feel safe, I have to say. I had it up around 2,000 RPM, 2,200 I saw a couple times, but I never really floored it. I don't want to overspeed this thing and blow it up now after all this work. I need to figure out a safer way to be able to do this. $700 on the crankshaft pulley equals 1,700 there. So now I can check the RPM there and know where I am. It's 2.428 blah 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 to 1. If I want it to be 3,000 RPM, I multiply that by this. So I want my tach to read 7285. That will be 3,000 RPM on the crankshaft. Alright, I have my lovely assistant up there. She's going to push the gas while I'm checking the RPM. This turns the max speed down a little bit. Alright, I didn't get it all filmed, but with Jennifer pushing the gas and me checking the RPMs here, I got it really, really close, maybe just a touch over, and I don't want to push this engine too hard, so I'm going to back off just a hair, and we're going to call that good. It's idling really well, right around 700. Let me tighten down that nut, and then we need to just go in on the buffer until the running smooths out just a little bit. So the camera didn't really capture this part very well, but you can kind of hear when it's idling there's a slight change in the RPM. It kind of cycles up and down just a tiny bit. So I'm listening to how it's running as I'm turning this screw in, and I hear a point when the RPMs kick up just a tiny bit, and it also stabilizes. And that's the point where I tighten down the lock nut. So the spec is 700 plus or minus 50 RPM. I did want to mention getting the upper RPM set on this is very important, especially this engine, because you have it floored very often. Yeah, the driver is going to be on the throttle on this low power beast. Listen to her purr. She does like to run. We've got a leaky valve cover gasket. 2 spots. It's leaking here too. Yeah, look at this. It's the compressor. See down there? Oil starts right at that junction where I made that new gasket. Why is that leaking? Well, I know why they weren't particularly tight is because there's just not good access to tighten them. But here's what I'll do. Yeah, definitely use a little more. break the crow's foot? Well, that's what I can find of it. I got it a little tighter by hand, but I also did a double wrench method and was able to get this really tightened down. But I did that off camera. Let's put this cover back over the governor adjustments. All right, I've got the oil right on the money. It's right on the full mark. And that's how we're going to tell if I fix this problem or not. After running this thing for a while, we'll see where that oil level is. If it's climbing, well, the only place I could think it would be coming in would be through a cracked head, because that fuel gallery going down the center, if it's got a crack and it's able to run down into either the crankcase or the cylinders. I put a sealing washer on this leaky bolt here, and we tightened the compressor down, so now when we get it up to temperature and check our exhaust temperatures, we'll also be checking for additional leaks. Yeah, this engine's always just been a nightmare to work on because it's constantly covered in greasy, oily nastiness, and that's why I got to get these leaks fixed. Actually, let me top off this coolant here. All right, I just filled it just to the top of the sight glass. Now, I know you guys can't see all that well, but that's right on that exhaust manifold. That's right on that one, 79 degrees. This one is also 79 degrees. And that one. People seem to think that this thing is casting an average of a big area. It doesn't do that. See if I can show you. Here's my finger. So right beside it, this piece of metal is measuring 82, and if I put it on my finger, 92. You know, that's an inch apart. 82, 92. So I don't know if there's cheap ones out there that average a big area. This one measures right where the laser is. If you still have doubts, let me prove it. Here's a rusty old bolt. I'll set that right there. We will measure the frame right beside it. It's 83. The bolt is 138. Right beside it, 82, 136. It measures what the pointer is on. Okay, we've been idling for about 5 minutes. This one is at 130. This one, 122. How do you get a reading? 120. This one, 130. 140. Okay. Actually, a little variation on that side. That was our good side. 126, 130, 140. This was our dead cylinder. 130, 126. Okay, I mean, all the cylinders are contributing, and it's relatively symmetric. I mean, it's not perfect, but I think that's pretty good. Let's put it under load. Well, not load, let's just speed up a little bit. Okay, we've been running for several minutes. Cylinder 1 is 175. Cylinder 3 is right around 200. Cylinder 5 is 187, 88. And cylinder 7 is 188. Let's go to the other side. These are the even number cylinders. So cylinder 2 is 190. Cylinder 4, I'm not getting a great reading on. Let me try over here. I'm getting 199, 196. Cylinder 1, 194. So those look good. And yeah, 196. Cylinder 6 is 190. And 8 is 200. The engine's still getting hotter, so I went back to the other side to check and see how symmetric it was, and I found several of them were also in the 200 range. clicking you hear sometimes are the valves in the compressor. Shut off. Yeah, I think I'm just going to see if I can tighten that a little bit. If it's already tight, I'm just going to put a washer on that to seal that. Other than that, I think this thing's ready for some work. How about that? Yeah, I'd say, especially once I throttled up, the two banks were quite symmetric. All the cylinders are contributing. I really think I should see a pretty good difference in the power output on this. I was at least 1/8 power down because I had one totally dead, but I was more than that because I think two cylinders over here weren't doing much. In fact, the whole bank wasn't doing as much as the other side. Now you can't really see that. There's a little bit of variation, but it's pretty symmetric, I think. So you don't have these tools and you need them. Well, what do? This is nothing more than a spacer, and it measures 0.216. And you don't need that curve on the end. You could certainly grind something to make it a little easier to use, but that's easily done. You're just going to need to file a piece of metal down until it measures 0.216. The bolt you know about, anyone can get a bolt. This thing, it's a little odd. I think you could probably loosen that lock nut and tighten it just with a punch and a hammer. Give it the old tappy tap, I think is an easy workaround there. These are just feeler gauges. Use regular feeler gauges. This is basically a nail and a bungee cord and a hook. That's easy enough to replicate. Just so you know, the part that goes in the hole measures 93 thousandths. The rest of this is just wrenches, so you can definitely do it without this kit. This is a little harder, especially this thing, but I 3D modeled one, and that's going to work just fine. I forget what size bolt I modeled it for, but there's plenty of meat on that. You can drill it out bigger, tap it for whatever size bolt you have. All that is a retaining bolt, just so when you put your dial indicator in there, it grabs onto the dial indicator. That's all that is. And you've seen, like I did at the beginning of the video, you can use a regular dial indicator. This is nice because it's easier to see when you're doing it, but you can do it with a regular one. So that covers this. Now, how do you hold it down onto the piece? This one is magnetic. The original Kentmore version had spring bolts in it with something sticking out on the bottom that you could put it on the injector and then hook it on the injector springs like that. This is just a hollow tube here. You could cut that open, put some springs in there, put a bolt down it. There's any number of options, but I think the easiest thing for you to do is going to be to glue a magnet right in there. Just epoxy a round magnet so that it will hold itself down like this one does, because that one is a magnet. The gauge block I also 3D printed. Now the thing with this is every printer is going to be a little bit different. What you need to do is make sure the dimension from the bottom of the step here to the face is 47.7 millimeters. If you print it out and it's not, you can scale vertically in your printing studio to change that dimension. If you get it really, really close and you want to get it a little better, you could file a little bit off the top. Just leave it a touch high and just file that down. As long as that is 47.7 millimeters, that's all you need. Then you can put your gauge on there, you can hold it down, set your dial indicator on there, and zero it. So pretty much with these two prints, all you need is a bolt to hold the dial indicator and a dial indicator, maybe with an extension. It's got to be long enough to reach all the way down there. So now you won't be in the position that I was in, trying to find these tools and figure out how all this stuff is supposed to work.
Here I am driving this beautiful dump truck that's in such good shape. I just have to say, I think I'm probably at least 10 or 15 years older than this. I don't think I look this bad. I mean, maybe I do. I don't think so.
So we are going to pick up some piles of compost that have been laying around the farm. These were hay bales and places where we fed the cattle last winter. We generally only feed when there's enough snow on the ground that the cattle won't eat through it. And wherever you put a hay bale, you end up with a very dense mat of hay that gets stamped down onto the ground. And if you just leave it there, it ends up kind of killing all the grass in that area and it grows up with a bunch of weeds. Well, when the cattle are all congregating around a hay bale, you end up with a lot of manure there too. So you've got this dried hay and manure, which those two put together are going to make great compost. So what I do at the end of winter is I stack it all up, and I've been turning it periodically with the skid steer. And now it is mostly broken down. This pile especially is just about done. That's just about pure compost there. And we're going to gather it all together into one giant compost pile that we're going to store over near the garden. This is the second pile, which is also a pretty small pile, but you can tell it's not nearly as broken down as the first one was. The third pile is also a small pile. All of these probably came from 1 or 2 bales of hay, and this is where the cattle happened to be when it snowed and they needed it. Now the last pile is a different story. That's where the cattle were last winter when we got 2 big snows right in a row. So they were there probably for a week and a half, if not more, and they went through many bales of hay on that spot. So it was a huge pile. It's much smaller now because it's been composting and it's broken down a lot. But that's where we're headed now. Yeah, the camera never does it justice. So this truck can hold 15 yards, and there's almost 2 loads of compost in this one pile. Yeah, there was another pile here, but we're not moving this one.
This fall I'll throw some grass seed down on this. It'll probably grow like crazy. Here I'm turning in the buffer screw just a bit more. So I did notice, especially when I was running it hard, the engine was kind of cycling up and down, and that's what that buffer screw is supposed to do. So I just turned it in a little more. Hopefully that'll fix it. You know, if not, I'll keep fiddling with it. It didn't do that before, so I should be able to find the right spot. See how our oil looks. That is right on the money. If you guys can see that, it's definitely not high. And we ran it quite a bit. I think it would have been high with what it was doing before. So I'll keep my eye on that, but I do think that at least, that problem is fixed. What's the other problem? It's still a piece of So there you go, guys. The old Detroit went through the fuel system, survived it, and I think we fixed the problem. I will definitely keep you guys updated on the channel if anything changes with this truck. Now, was this all worth it? Ask me in 5 years. You know, if the engine goes for another 5 years working around the farm and gets a lot of stuff done for me, well then yeah, it was worth it. If it dies next year, that was an awful lot of work for, for not much. So yeah, that's just what you get. It's kind of a crapshoot when you're working on an old engine like this, especially this type. You just don't know what else is right at the end of its rope and getting ready to break. So we'll see. But that's just strictly for this truck. For me, this was really interesting. I learned a lot, and I'm glad I went through it, and hopefully share that with some people that might have the same engine or a two-stroke Detroit and want to know how to work on theirs. So that adds much more value to it. So yeah, it was totally worth it. That's all I've got for you on this one. Over 2 hours of video. I think that's long enough. Thanks for watching, guys. We'll see you on the next one. Oh yeah, and did it have more power? I think it did, but I mean, the bar is very low. You're talking about, is it now ridiculously underpowered or horribly underpowered? I think there was a little bit of a step up in power, but it's nothing to write home about.